This is Pre-Calculus, Functions and Graphs. I'm Mr. Stark. We're wrapping up Topic 6, and this is Lesson 6B, Combining Transformations. You can follow along using this document, but make sure you watch Lesson 6A before you proceed. If you're good to go, let's get started. Let's learn how to combine transformations. When there are multiple transformations that we're performing on a function, we start from the inside and move out. What I mean by that is the transformation that's closest to x is what we do first. Usually that's a horizontal translation, stretch, or shrink. After we finish the first set of examples, we'll circle back to this idea. Here's the first example. We have a function y sub 1 equals x cubed plus 3. Our goal is to find equations for a vertical stretch of 4 and a horizontal shrink of 1/3. In Lesson 6A, we did a calculator nerd out session where we learned that if you multiply a function by 4, the graph is vertically stretched. So that's exactly what we'll do here. We'll multiply x cubed plus 3 by 4, and we could distribute the 4, so we get y sub 2 is equal to 4x cubed plus 12. In Lesson 6A, we also learned that if you plug in 2x into a function, the graph of that function shrinks horizontally, and it shrinks by a factor of 1/2. So if we want this function to shrink by a factor of 1/3, we should plug in 3x. So we have y sub 3 is equal to quantity 3x cubed plus 3. And that's equal to 27x cubed plus 3. Now let's circle back to the whole idea of transformations in order. I want you to see that in this second part, when we did a horizontal shrink, that 3 is close to the x. But in the first part, that 4 is on the outside of the function. So if these were combined, that horizontal shrink would actually happen first because the 3 is closer to the x. And if we did combine these transformations, the vertical stretch and the horizontal shrink, the new formula for the function would be 4 times quantity 3x cubed plus 3, close parentheses. Now let's do an example in which we apply multiple transformations to one function. The function that we'll use is y equals x cubed. The three transformations that we'll do are A, horizontal translation to the left 5 units, B, a vertical stretch by a factor of 3, and C, a vertical translation up 4 units. For part A, the C value is -5. So the new function is y sub 1 equals quantity x minus -5 squared. That's the same as quantity x plus 5 squared, so we could just write it like that. For part B, we're stretching by 3, so we'll multiply the entire function by 3. So we have y sub 2 equals 3 quantity x plus 5 squared. For part C, the C value is +4, so we have y minus 4 equals 3 quantity x plus 5 squared. Then if we solve for y, we have y equals 3 quantity x plus 5 squared plus 4. And we could call that y sub 3 if we want to. We could also expand that out, but there's really no need to. Now let's perform those transformations graphically. We'll do it one point at a time. So I'll put my pointer on 1, 1, and if this was on paper, I'd put my pencil on 1, 1. I translate to the left 5 units. The y value at that location is 1, so to do a vertical stretch by 3, I multiply 1 by 3, which is 3. So I move my pointer up to 3. And the last step is to translate that point up 4 units. So I go from 3 up to 7. So the point 1, 1 got transformed to the point -4, 7. Let's do 2 more points. 0, 0, move to the left 5 units. The y value is 0, multiplied by 3 is still 0, and translate up 4 units, and we're at -5, 4. The last point we'll do is 2, 4. Move to the left 5 units to -3. Multiply that y value, 4 times 3, which is 12. So we go up to 12, and then we translate up 4 more units, up to 16, So we're left with -3, 16. Okay, fine, let's just do one more. -2, 4. Move it to the left 5 units, -7, 4, and then multiply by 3. So -7, 12, up 4 units, -7, 16. Now we could sketch the parabola through those points to get a final transformed curve. Notice that I didn't transform the point -1, 1. I probably should have, but we can see where it should be, at -4, 7. Here are the two curves sketched using technology. And that's it for Lesson 6B. Just so you know, transformations is an important thread that is sewn through the fabric of Algebra 2 and Pre-Calculus. We revisit transformations when we study quadratic functions, rational functions, exponential functions, logarithmic functions, and trigonometric functions. So don't forget this stuff and come back to it whenever you need to. Okay, that's really it. Thank you so much for watching.